And so now we will look at graphs of the trigonometric functions. So we'll start by doing sine theta, and we'll sketch it between 0 and 360 degrees, which is the same as in between 0 and 2 pi. And if we say this is 1 and this is minus 1, it'll look a bit like this. I haven't done it very well. I'll try and do it again. Oh dear. Something like that. Doesn't have to be perfect. So that's pi, that'll be 2 pi, or 360 degrees. And this is 180 degrees. Up here that's 90 degrees, or pi over 2. And here is 3 pi over 2, or 270 degrees. We call this bit the wavelength, or the period, because a sine graph, if we did it the whole way, it would look like this, and it repeats every 360 degrees, or 2 pi. And this is called the amplitude. And amplitude is also known as the maximum displacement. So I'll continue, before I get more into those things about amplitude and wavelength and stuff, I'll just keep going into the other graph shapes. Now cosine is the one I'm worst at. I'll do it's honestly, if you did, it's honestly a bit easier to go like this, and then this is 0 and this is 2 pi. That's your cosine, and it's like that. And again, 180 or pi, 2 pi or 360, 90 degrees or pi over 2, 270 degrees, 3 pi over 2. And this part's your amplitude. And again, it's got a period of 360. This has got a period of 360 degrees. And then tangent looks like this. And that's 360 degrees, 180 degrees, and 0 degrees. And you can see it's got an asymptote at 90 and an asymptote at 270. It's got no amplitude, well, undefined amplitude, because it goes up to positive and negative infinity. And it has a period of 180 degrees. And now I would like to say, and if we look at these functions and these graphs, they can be, if you remember the transformations of functions, we can make them go up, down, they're wider or shorter or whatever. And so let's think about the sine one. And think about this period, this amplitude, and by the way, these are called peaks and troughs, peak and a trough. And think about what we can do with these to transform them. How can we make this amplitude shorter, less? And we could do that by multiplying it by constant. So this is sine of x. If we did a sine x, then this amplitude would be a. So if we made a bigger, because it would then stretch out like this, like that, you know. But you would increase the amplitude, but if you made it smaller, like that, then you would be multiplying by like a fractional a. You could also add something like c, and we're just doing vertical transformations for now, and you can move it up, or you could move it down by adding a negative c. And the other thing would be a reflection. If you just did minus the whole thing, minus sine x, you would just flip it in the x-axis, and that's that would be what it looks like. And I should note that in physics this would be something called antiphase, and they'd actually cancel each other out, but when this isn't physics, this is maths. And so that's what would happen there. Now, what could we do about the horizontal stuff? Now, the easiest one could be x minus sum b, and we would move it along by we would move it to the right whatever b is. So if we were moving to the right negative amount, we'd be going to the left, and you would be subtracting a negative b, which means you'd be adding something. But if you just subtracted a positive b, you'd move it to the right. And then if you did a multiplication of that x, you would squish the function. And a way that I try to think of it is, this thing tells you, multiplying x by x tells you almost a frequency of the sine wave. It tells you how many complete cycles of A will fit into 360 degrees, its normal period. And so if that was sine of 2x, it would look like this. Something like that. It would be squished, yes, but it would mean that the number of repeats in a certain set of space, a certain period, would be doubled. And obviously you could do sine of minus x, and then that would just be flipping it in the y-axis. So that would be, well, that's actually a good thing to note, because you flip it in the y-axis and you get that. But it's one thing I would like to note here is that when we do this thing here, which is our sine of minus x, and then we look back up here, and when we did our minus sine x with the minus on the outside, they're the same graph, right? The same shape. So then that's why we can say that sine of minus x equals minus sine of x. And essentially we can do these same transformations with tangent and cosine. And the other thing for cosine is with that thing, if you did cosine of minus x, that's just equal to cosine of x. Because if you flip that around, it's got symmetry about x equals 0. So that's an introduction into the graphs of trigonometric functions. In a later video, we will be using both the graph and the unit circle to explain multiple solutions of trig equations.